Hi guys, let's try to solve the next task. So the next task for today is coin change. I will revert my code. And yeah, and let's try to solve this problem. So we have coin change task. And what is this? So you are given an integer array of coins, 1, 2, 5. And this represents a different denominations of coins that we have. And we have some amount of money that we have to receive. And we should return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. And you may assume that you have an infinite number of each coin. So let's get checked. So we have some coins, right? So the first question, what is the length of these coins? So I expect that the length would be, so we have at least one coin, and here we have, let's say, I don't know, 20 coins. Then I have coins I, so I expect that the coins doesn't have negative values, so it would be from 1 to 20. And yeah, and also I have my amount. So by amount, I can get like from 1 to, let's say, 1 million. So let's check constraints. All right, so I have 12 coins. Here I can have really big max integer values from 1, and amount can be 0 and 10 on the fourth power. So if my amount is 0, then I should probably return also 0, as we see here. Okay, let's try to build some test cases. So the first test case, it can be like this. So we have coins like 1, 2, 3, 4, and we have amount equal to 10, right? So what would be the algorithm? So we can try to get the most greatest coin, like we take 2, 4, 4, and then we take 2. So the logic is we take in the maximum until we will reach this maximum, then we try to take this one, and then this one. And in the end, we just return this 3. But we can have, I think we can have something like this, right? Something like this, and amount let's see, 1, 2, 5, 7, and amount. So I need some coins where, so I have 2, 5. And for example, 10, right? So with this logic, I take first 7, right? Then I need to take the laters, so I take 2 and then 1. So I have 3 coins, but here I can take 5 and 5, and it would be like 2 coins. So the logic with taking the maximum is incorrect, actually. So what can I do? I can try to build all possible solutions that I can get. like I can go for each coin and decrement my amount. And when I reach 0, then I return the number of options that I get, right? The number of coins. So it should be the minimum number of coins that I get. So what can I try here? So I can try DFS call with my current coin, current amount, like let's say that amount, I will decrement my amount. So I have like current coin, I have my coins, I decrement this amount, and also I have like how many coins actually I take. And I should also have like integer minimum, and minimum would be 0. Right, okay. And let's do like if amount is equal to to 0, then I return 0. And here I return minimum equal to 0, I return -1, otherwise I return our minimum. And let's implement this function. So this function would be white. Here I would have I. Here I would have coins. And coins, it's array, and also current amount. And so I calculate, what can I do? So first of all, I can check like if I is equal to coins length, then I just return here. Then I take my coins I, so it's my current coin. And my current amount, I decrement my current amount, my current coin. If I is equal to length or current amount less than 0. If current amount equal to 0, int coins count, and so this minimum will be integer max value. Okay. So if my current amount is equal to 0, then my minimum will be equal to mass minimum between coins count and minimum, and return. Okay, and here I do this from 0 to I minus coins. Yeah, maybe I don't need this. I don't need this I. Coins lengths I++, and it's DFS. And here I call this DFS function. I call this DFS function with I. No, coins count plus 1. Okay. Then coins, and I have my current coin, and here will be current amount minus current coin. Okay, and I return, yeah, I'm actually returned from here. So let's try to run. Okay. Yeah, here I need this I. I need I because I need to understand from what do I need to understand? Current amount. Maybe here like current amount and current coin, it will be coins I. Something like this. All right. So accepted, let's and submit. I think it would be TTL. Yeah, TTL, like TLE, time limit exceeded, right? So when we have this amount and this number of coins, actually we have time limit exceeded. So what does it mean? It means that we are doing a really, really big number of iterations. And at some point, we need to understand what are we returning. So so what can we do here? We can, I think we can try to use memoization. We can try to use memoization here. But how to do this? We have coins count. So we can also add maybe another like thing, like if coins count is greater than min, we return. Greater or equal. So in this case, we skip all like other combinations. So let's run this test case. Yeah, but it's still time limit exceeded. Yeah, it's like calculate like 100 for ones, then it calculate 99, and then 1 like 98, and then 1 2, and so on and so forth. So what can we improve here? By improving, I think we can like sort, for example, it and go one by one. So if we at the beginning, for example, do like arrays sort coins, but we should sort in reverse order. Then I believe that it will be faster. But how can we use memorization here? How can we use memorization here? But I think this idea with sorting is nice. Let's try to do this. So we have like, I don't remember, like sort array in reverse order Java. Descendant, yeah. Okay. You could use this sort all kind of objects. Okay, but it's when we have objects. Okay, so an array of reverse order sort. Okay. Okay, so I think we can take this one and let's try to sort it. So we have our coins, and here we have int sorted coins. And let's try to run it. Yeah, it's still time limit exceeded, even with sorted. Yeah. Coins count. Maybe we can try to do the following. Maybe we can create some key with each coin, or take this current amount. Like, can we say that current amount minus this coin will give us some minimum number of values? It's a minimum number of values. So for example, after this one, I done this DFS, right? And I know for when I take coin 1, I definitely know the minimum number of coins I need to take for this amount. So, for example, if I have amount 10, right, and I take first coin as 1 out of this 10, so my current amount would be 9. And I know that I take 1 coin here. Do we have some hints? Maybe no, we don't have. Yeah, it's dynamic breadth first search, so it's not DFS. It's BFS. Okay. We have 1, 2, and 5. We have an 11 as our amount. And we take 10, okay. So we do 10, 8, and 6. Then from here, we take 9. Oh, okay. So maybe not DFS. Maybe we can implement it with BFS, and then it could work. Let's try to implement it. So with BFS, we have a queue, integer, new priority queue, not priority, just queue, linked list. Okay, we add amount. Okay, and while queue is empty, false, we are doing some operations. So what kind of operations? So we should have array list. Here, while queue the same thing. Queue poll. So it would be current amount. And for current amount, what we are doing, we iterating over our coins. And if my current amount minus coins I is greater than 0, I just add to this list. I add to this list actually these results. else if my current amount minus coin is equal to 0. This means that for this amount, I have yeah, I have number of coins. For this amount, I have number of coins. 6. Yeah, but I need this number of coins, right? So maybe I can, in the queue, I can put not only amount, but also number of coins, like the pair of elements. Amount and number of coins. It's 10, 9. Yes, so for example, when I have my tree, how it will look like. I have 11, then I have 10, then I have 9, and then I have 6, right? Okay, then for 10, I have 9, then I have 8, and then I have 5. Then for 9, I have 8, I have 7, and I have 4. Then for 6, I have 5, I have 4, and I have 1. So we see that for this number of nodes, for this 8, I already calculate. So I can have a memo with integer. So this would be amount, and here it will be number of coins. So it will be memo, new hash map. Okay. Okay. And yeah, in this case, what I have 10, 9, 6, 8, 9, 8, and so on. So first I'm going to the left, and I have current amount and number of coins. So current amount won't be 1. 1. Yeah, I need to know. I need to know for this 9. I calculate all possible. Okay, spaces. And then for 9, I know it. So maybe DFS even can be better. Let me think. Let me think. Yeah, because if we look forward, it would look like for 9 I have 8, 7, and 4, right? Then if we go forward, for 8, I have 7, 6, and 3. Then for 7, I have 6, 5, 6, 5, and 2. Then for 6, I have 5, 4, and 1. Then for 5, I have 4, 3, 0. And actually, when I have 4, 3, 0, I can tell that actually for 5, I already found solution, right? For 5, I already found solution. Because it would be 0. So for 5, at least, I know the optimal solution. So if I have amount of 5, then I can return 1. Then for 6, I know if for 5, 1, for 4, more than 1, and it's this one, it would be also 1. So I can say that for 6, I can return 1 or 2. Yeah, so maybe this would be better. Yeah, maybe not. Yeah, BDFS would be better, but here in topics we have BFS in discussions. Okay, so let's try to implement maybe not BFS but DFS. So we have DFS, And we have our coins. We have current amounts. And when we on current amount 0, we return from here 1. Okay. So what I have coins, amount, then I should return from here. So I have my DFS. Here I have coins, amount, and also I have my memo map. So in my memo map, at the beginning, I just iterate over each coins and just put coin 1. Here I can say that if current amount, like if memo get amount not null, just return from memo get amount. If go amount, okay, right, then I iterate and check 5. Okay, I don't have 5, they have 4, 3, 0. I should have like integer result for each amount. For each amount, yeah, memo get, and yeah, for each amount I should get the minimum. For example, for 4, yeah, let's go for the 4 forward. So for 4, I have 3, 2, and here would be 4 minus, like minus 1, right? So for 4, I cannot get yeah, with 4 and 5, I cannot get anything. So my if amount would be less than 0, should return minus 1. Then if amount equal 0, then I return 1. and here -1. Yeah, so it can be the case when, for example, for -1, I just return -1, like for 4. So let's imagine I have 4. So with 4, I go to 3. For 3, I have 2, 1, and 2, 1, and -2. Then I go for 2. For 2, I have 1, 0. And -3. And then for 1, I have 0, and so on. And for 0, actually, I return 1. So for 2, I return 1. Then I return 1. And if it's not, -1. So let's let's have it integer max value and go by every coin. And call DFS over coins, and here amount minus coins amount minus coin C. And calc if calc not equals -1, I do result equal mass minimum. So I just return minimum from result calc, and here I put into memo amount, and and my result would be equal. So if result equal to integer maximum, then it should be -1. Otherwise, it should be result. Here I put result and return also results. Yeah, and here return minimum. This minimum result if I return from here, Oh yeah. This I should copy. Mm-hmm. Mm-hmm. Okay. This calc result. Yeah, so when I'm on 3, for example, no, when I'm 5, I return 1. Then, like, I have 6, right? So I don't have anything. So 5 return 1. 4 return me 3, 2, minus 1, and it should return 2. So how it would return me 2? So I have 4. I do calculations with, yeah, I don't need, yeah, I think that I will not take much time, so thank you very much.